So we left off and the notes around this section with problem 1. And you have point and slope. And what we had was the point slope form. And we took that and we made an equation. Y minus 1 equals negative 3 times the quantity x plus 7. We can take that, and if we keep simplifying, we can get it to slope-intercept form. And that's what you're going to have to be able to do eventually. Let's take a look at problem 2. Okay, if you're given 2 points, so you have different problems. This is a second type of problem where you'll have 2 points, and it'll ask you what is the equation of the line. The best thing to do here is to take this, and first you want to find what the slope is. So we'll take a pause here and find slope. I want to be clear on what we're using here. So we're taking the second y value minus the first y value. And we're taking the second x value minus the first x value. And when we do that, we get 7 over, and this will give you a positive 5. So we're talking about 7/5 as our slope. So now we can write it in slope-intercept form with the slope plugged in plus b. You don't need the parentheses there. You could keep it as 7/5. But I'm going to keep the parentheses there because what I'm going to do is we're going to put one of the values in. So now, once you found the slope, you can take one of these points. Now, my suggestion is to take the one that's 0 and 7 because there's a better chance that we'll make a computation mistake with a negative 5. So I'm going to suggest taking 0, 7 as our coordinate pair because that's an x value and that's a y value. If we know that, we can substitute them into this equation and solve for b. So I know y is 7, x is 0, plus b. We take this over, we have 7 equals, well, 7/5 times 0 is just 0, plus b, and b is equal to 7. So, first step, find slope. Second step, find b by substituting in one of the coordinate pairs. And now, step 3, write it all together. Y equals 7/5 x plus 7. Okay, let's move on to problem 3. Write an equation in standard form. So standard form, if you recall, is ax plus by equals c. And it's giving us what is an equation of the line y equals 9.1 times x plus 3.6 in standard form. And then it tells us we're going to look at Karina's work. So if we look at this, she writes the equation. There's nothing wrong with that. Here, it looks like she's going to multiply both sides by 10. Well, why the heck would she multiply both sides by 10? Well, if you think about it, when you multiply decimals by 10, it's really just going to move the place over 1. 9.1 times 10 is 91. That's correct. But this is distribution. So she did that correctly. When we look at this, she didn't distribute to get 36. This should be 36. And that's kind of what we want. 10y is fine. So it really should have been 10y equals 91x plus 36. And the other error is she didn't get it into standard form. So if we're going to get into standard form, all she would need to do, or all you would need to do, is say subtract this term, and putting it in standard form would go like this: 91x, since the x term is first, plus 10y, equals 36. That's what it should look like in standard form. So, first of all, first error was distribution. Didn't distribute correctly. And then the simplifying was not completely done. And we corrected that with this move of the 91x. So this is now in standard form. So that was 91x plus 10y equals 36. So now we move to problem 4, which is actually has a lot to do with standard form. When we graph using intercepts, remember, is a good note to make, is an x-intercept is when a line crosses the x-axis. So if it's going to cross the x-axis, it's some number, we'll call it a. 0 is the coordinate. So there's an x value, and then there's a y value, but the y value is always 0. Always 0 for an x-intercept. For a y-intercept, it's just reversed. So we have some 0 value as the x term. That's always 0. We're talking about a y-intercept. And then we'll call it some number b as the value going up or down the y-axis. And that's good to know here. Alright, so we write the original equation. We have 2x minus 4y equals 8. And they say substitute 0 for the variable. Well, where do we get that 0 from? So if y is 0, that means we're looking for an x-intercept if y is 0. When we do that, I'm just going to work down this column first. So we're going to split this. This is the x-intercept work. This will be the y-intercept work. And you want to do this whenever you have a standard form. So when we do that, we get rid of 4 times 0 is just 0, so that's gone. Then we have 2x equals 8. And we can do that mentally. We know that's 4. So in reality, we know 4, 0 is one of the coordinates. So I can take that and go over 4, up 0. There's the x-intercept to this equation of 2x minus 4y equals 8. And now we go ahead and we do the same, but now we do it for y-intercept. So we plug in 0 for x. So we know 0 is going to be the first coordinate. This is gone. Negative 4y equals 8. Divide that, negative 2. Negative 2 is the y-intercept. Go 0, down, 2. And all we do is we plot those two intercepts, connect them, draw your arrows, and normally you'd label, say, 2x minus 4y equals 8 and label it. So everything's proper there. We have the arrows, the plot's pointed, the line through, arrows on the end, and label the graph. Okay, in problem 5 we have more of a word problem. The office manager of a small office ordered 140 packs of printer paper. And that said it was going to last about 80 days. So they give us the table of values. So that's like the first step, build a table. And we really only need 2 points here. So this is just the same as doing the intercepts that we did before. Packs of paper used, well, on day 0, none of them were used. And then 80 days through, 140 packs were used. So when we do this, we just take the plot. I have 0, 0 in the origin. Plot that point, and then over 80, up 40, 140. So x is going to be days, and our y is going to be packs. And that should do it for this problem. So here's a nice problem that involves all 3 forms. You start with standard form, and it's asking us to circle the line of the slope of the line. Circle the slope of the line. So if we take this, we want to actually turn this into slope-intercept. So slope-intercept form is what we're going to turn this into. So if I take this 4x minus 2y plus 2y equals 7, and I'm going to move the 4x. I'll go over here. 4x's cancel, so we're left with 2y equals, I'm going to write it in slope-intercept form, so I'm going to write the x term first, plus 7. It's a positive 7, so that's why it's a plus 7. Divided by 2. Slope-intercept form, well, we can take this as fraction. Negative 4 over 2 is going to give us negative 2x. And then we have to simplify this one. And we could leave it as plus 7 halves. Or if you want, you can say negative 2x plus 3.5. Either one, these are both in slope-intercept form. And now we can look at this form and say, alright, what's the slope? Well, negative 2. So that's going to help us. So we're going to take this and we're going to write a new equation for a line that actually goes through this coordinate, xy. So we have a point, and we just identified a slope. So the next question asks us, what are we going to use? Well, point slope. We can easily use that to create a new equation. First y doesn't change, minus y1, so the coordinate y value is a 2, equals m, so we know the slope is negative 2, times this x value doesn't change because it's part of the equation, x1, well that's a negative 4, and now we have some simplifying to do. I simplified by saying negative minus a negative is plus 4, and then we can distribute negative 2x minus 8, and then don't forget we have to add that 2. Add that 2, add it to the like term, and the like term is negative 8. So when we simplify it, we get negative 2x minus 6. And that's your equation. So this is an equation that has the same slope as the original equation. They're both negative, and they would look something like this. Not perfect slope, but if I took that off of a graph, that's what they would look like. And what you just did is you basically wrote parallel lines because the slopes are the same. Slopes are the same. And that's what we want to know about parallel lines.